So we're talking about the unit circle today. And what a unit circle is it's a circle whose center is at the origin, and it's got a radius of 1 unit, hence the term unit circle, right? The radius of it is 1 unit. So the center is here, and the radius is 1 unit. That means, you know, that length is 1, that length is 1, that length is 1. You get the idea, okay? So what does that mean? That means if I were to inscribe a triangle in here, right, a right triangle, what part of the right triangle is the radius? It's the hypotenuse of the triangle, right? The radius is the hypotenuse of the triangle. Now, if the radius of the unit circle is always 1, that means any triangle I draw in there can only have a hypotenuse of how much? 1 unit, okay? So that's the important part. All triangles drawn inside the unit would have to have a hypotenuse 1 unit long, okay? That sort of creates a problem because until now, when we draw these 30, 60, 90 triangles, right, we have these legs of 1 and √3, and the hypotenuse is 2, okay? And remember, I always say, we're going to change this, we're going to change this. Well, now's the time we're going to change this. If the hypotenuse of this circle is 2, can it possibly fit within this circle? It cannot, because if I wanted to fit this inside the circle, the hypotenuse must be a 1. So what I have to do then is I have to rescale my triangles. And to rescale a triangle is like rescaling a picture, right? You can't just shrink it on one side. You have to shrink each side proportionally. So here, this is what we're going to do. We knew that the radius was 1 when we were doing the quadrantal angles, but we haven't done the other angles yet. Okay, the pi over 3 and the pi over 4, we haven't done those yet. So we're going to rescale the triangles. Now, normally this was a 1, a √3, and a 2. Okay? Now, what would I have to do to that 2 in order to make it a 1? Divide it by 2. Thank you. We're going to divide it by 2, divide it by 2, divide it by 2. When I do that, now I have a brand new triangle. And the sides of my triangle are, I'm just going to erase this because we're no longer going to use that. Now the sides of my triangle are half, √3/2, and 1. And that's what we're going to use from now on. Everything else is now archaic. This is what we're going to use from now on. So let me ask you this. Suppose you wanted to find in this triangle the sine of 30. It would be the opposite leg over the hypotenuse, right? That's how we would do it previously. Well, if I do that, it would be 1/2 over 1, which is how much? 1/2, right? Now, what would the cosine be? This over 1, right? So the sine of it would equal 1/2, and the cosine of it would equal √3/2. So when I do it this way, do you see how sine of 30 is just equal to the opposite side? And the cosine of 30 is just equal to the adjacent side? Do I even have to mess with this hypotenuse business? Not anymore. All right? It's totally the same, but the language is different, and it does make a difference when we move on from this and we're doing pre-calc and everything else higher, okay? So we're going to do the same thing for the 45, 45, 90. It used to be that we had sides of 1, 1, and √2, right? Now, to make this into a 1, what do I have to do to the √2? Divide it by √2. And if I do it to one side, I've got to do it to all the other sides, right? So now I have 1 over √2 here, and if I were to rationalize that, what would that equal to? Right? Root 2 over 2, right? So it would be equal to root 2 over 2, root 2 over 2. So now watch what I'm going to do. And that's just the 1 in the hypotenuse. So let me erase all that other junk. And now I have this. So now that I have this, here's how I, Miss Malikian, will do this. Okay, this is how I do it. Okay, I need to find the sine of 30 degrees. Okay, I said to myself, all right, 30 degrees between these two, that's the smaller angle. It must face the smaller side, right? Is that true? So now if I want to find sine of 30 degrees, that's the side that the angle faces. Oh, that's 1/2, so it's 1/2. All right? Now, let's do one other thing before you become like total experts on this. Okay? All right, so here is my 30-degree angle. What I'm gonna do now is I'm gonna place a rescaled triangle inside the unit circle. So now this is gonna be one of my rescaled triangles. If this is the 30-degree angle, how much is that side now with our new notation? How much is it? It's 1/2. And this is root 3 over 2. And that's all I care about. I don't care about hypotenuse anymore. That's just archaic. We did that in geometry, not anymore. This is all I care about. It's 1/2 and root 3 over 2, okay? So now, how many different possibilities are there for the sides? There's the 1/2 and the root 3 over 2. So how many different possibilities? 2 different possibilities, all right? Now, between the 1/2 and the root 3 over 2, which one's the smaller one? The half is the smaller one. It must always face the 30 degrees, okay? Because that's the smaller angle between 30 and 60. Are we good with this? Yes? Sort of? Okay. So now, if I wanted to go from the origin to that point P, and I could only go horizontally and vertically, all right? How much would I be going horizontally? What's that distance that I'm going horizontally? Root 3 over 2. So that x value here is root 3 over 2. Okay? And how much would I need to go up? 1/2. So that's 1/2. Okay? We're good with this? Okay, so now, so we did labeling the sides of the triangle. We filled in the coordinates for point P. Okay, let's find the cosine of 30. How much is the cosine of 30? Root 3 over 2 I hear over here. Okay, how much is the sine of 30? It's 1/2. Okay, so now, can you come up with any conjectures having to do with this and the chord, like a statement? Can you come up with, can you make any inferences? Can you make any, can you see any pattern, any connection between the sine and the cosine of 30 and the coordinates of this? Yeah. Right, so you see how the x value here just ended up being the cosine of 30 and the y value ended up being the sine of 30, right? We've seen this before and now you're seeing that, okay, this is a thing, right? So the x value is equal to the cosine of theta, or 30, and the y value is equal to the sine of 30. And that's a thing. You just have to remember that. We're just gonna remember, right, that the cosine of the angle is always this horizontal side, and the sine is always the vertical side. So, which side is always the horizontal? What is the horizontal always? The sine or the cosine? Sine. Okay, one more time. What is the horizontal always? The sine or the cosine? The cosine. What is the vertical? Sine. The sine. So now, is the sine the x or the y coordinate? The y coordinate. Is x the sine or the cosine? Cosine. It's cosine. And what is the sine? Y. Y. And x is what? Cosine. And y is what? Sine. Sine. And that's just it. Okay? So. But is it always going to be a 30, 60, 90? Or it's either going to be a 30, 60, 90, or it's going to be a 45, 45, 90.
So these are not, what you do in rescale triangles, it's not for triangles that have like different angles.
No, these are for the special angles, right? Okay. I mean, you can put in a triangle that has different angles, but we just don't do that because we can't do it in our head, right? So the ones that we can do mentally are the special angles. All right. What this says here is exactly what you guys just came up with. That if you have a point, x and y coordinates, then x is the cosine and y is the sine. All right? So now, let's put in here a 60-degree angle. All right, remember I draw my angles this way, 60 degrees. Okay, so that's the 60-degree angle. Okay, now, is 60 degree the smaller or the larger angle between 30 and 60? It's the larger angle. And if it's the larger angle, does it face the larger side or the smaller side? Which one? The larger side, right. So then this side that it faces, if this is 60 degrees, that side must be the larger side, right? Now, what were my possibilities for the sides of my triangle? It's 1/2 and what? Root 3 over 2. Those are the only two possibilities. So if this is the larger angle, it faces the larger side of what? Root 3 over 2.
Why is the 60 where the blue line is? Wouldn't that be 30 because it's the reference angle?
Well, no, I didn't. I was labeling the line, not that angle. The angle is really this one. I just labeled because it's going to get crowded in a little bit, so I was just saving space. All right, so 60 degrees is the bigger angle. It faces the bigger side. So what's this side over here? Half. So now, I'm walking down the street and somebody stops me and they ask me, what's the cosine of 60? Immediately I think, okay, 60. That's the larger angle. It faces the larger side, but cosine is this one. It must be 1/2. And yeah, I could do it a little bit more quickly now, okay, because I've done it a billion times. But that's how we're going to do it, okay? Now, if I have then, if somebody stops me and they ask me for the cosine of 30 degrees, then I say to myself, oh, 30 degrees, well, that looks like this, right? 30 degrees is the smaller side. It faces this, it's the smaller angle. It faces the smaller side. So this must be how big? Not half. I'm trying to erase that one. Root 3 over 2. Okay, so 30 degrees is the smaller angle. It faces the smaller side, so this must be root 3 over 2. Okay? Now, what about the 45, 45, 90? Okay? So take a look at the 45, 45, 90. How do the legs of that one compare to each other? How do the legs of the 45, 45, 90 compare to each other? Is one bigger or smaller? They're both the same. And how much is that length? How much did we say it was with our rescaled triangle? Root 2 over 2, right? So for the 45, 45, 90, it's root 2 over 2, root 2 over 2. Okay? Now, here's how we're going to use all this. You have, take a look at this one. You have an angle. The terminal side intersects the unit circle at root 3 over 2 and 1. That means to get to the, 1/2, sorry. To get to that point, I have to go an x distance of root 3 over 2 and a y distance of 1/2. Okay? So, what is the cosine of that of this angle? Root 3 over 2. How do we know that? Because it's always the x. What is the sine of that angle? 1/2. Okay, so now, you don't have to draw it. Not at all. Not at all. That's the whole point. So now, write down the cosine and the sine for this one. Quickly, you have exactly 20 seconds. Write down the cosine and the sine for the next one. Quickly, quickly, 10 seconds now. You're gonna drop. You're gonna drop. So what's the cosine on the side? Just so we can have the order. Okay, what are the coordinates of this one? What's the x coordinate here? The x coordinate is √7/4, right? And what's the y coordinate? 3/4. Which one of those is sine of theta? Is the x or the y? The y, so it's 3/4. And what's x? Cosine of theta, √7/4. All right? All right, I'm going to give you guys one more example. This may or may not be a thing, but, okay. So, think about this one. Don't worry, you don't have to move it. Think about this one. What would be the sine of theta here? Mama, what would be the sine of theta for that one?
The sine of theta would be,
Yeah, 4. Yeah, 3/4. So what would the cosine be here? -5/2, and that's all it is. All right. Okay. So now here it is. This is it. This is the point, the reason why we're doing this. Okay. Earlier we learned about 3 steps, right, of how to evaluate trig values of any old angle, and the 3 steps were: find the reference angle, find the trig value at the reference angle, and then determine the SIGN sign, right? The SIGN sign. Okay, so that's what we're going to do now. Okay, cosine of 480, right? So first I need to find the reference angle, right? Huh? Is it 60? How do you know it's 60? It is 60, but how do you know? Okay, so how does 480 look? If you go around the circle, that's 360. I need to go another 120. So this is 60 degrees, right? Okay, now.
but it should go the other way because it's counterclockwise.
Right. How does the clock run?
Yeah.
The clock runs this way, so I need to go that way. So here we go. 360, 120. This gives me a balance of 60 degrees. Okay, so let's do that again. Yes. Okay, so the reference angle, how did we, okay, so are we all in agreement that it's in this quadrant? Okay, the reference angle is defined as the angle between the terminal side and the nearest x-axis. So the reference angle is between the terminal side and the x-axis. The x-axis, not the y-axis. I know that normally the y-axis is like, you know, it's huge, right? The y-axis always plays an important role. When we're doing this stuff, it's all about the x-axis. Was it in this class that I was saying, like, it's like the x-axis is like the Queen of England, and then the y-axis is just the husband that just tags along, right? So when you're doing this, it's all about in reference to the x-axis, okay? So 60 degrees. Now, if the reference angle is 60 degrees, I need to evaluate cosine at 60 degrees. So again, here is how I, Miss Malikian, will do this. 60 degrees is the larger angle. Then it faces the larger side. How much is the larger side? √3/2. The cosine is this one, which is the 1/2. So cosine of 60 is 1/2. Okay, now, in this quadrant, is cosine positive or negative? I have a negative. Is it a negative? So it's all students take calculus, so it's negative. That means the final answer is -1/2.
That's how it's if it's false, the sign would be
Yeah.
positive in that quadrant.
Huh? 60, you compare, it's always between 60 and 30. 90 is not a thing, it's the acute angles. It is the bigger side. Cosine is this one, right? Okay, guys, look. Yeah. Okay, Hannah's explaining something. Milan, we can do that later. Hannah's. Okay, so look. I'll go over it in a second, Maya. Look up here for a minute. 60 is the larger side, okay? A 60 is the larger angle. It faces the larger side. But would that be sine or cosine if it's this one? If it's the vertical? It's the sine. Is that what I want, or do I want the cosine? I want the cosine. So I don't want the root 3 over 2. The other one is the 1/2. Right, but then if it's in this quadrant, it would have been positive 1/2 because cosine is positive there. Here it's negative. So what quadrant it faces fixes the positive or negative. Let's do one more, right? Let's do one more. So I have 690. In what quadrant would 690 fall? So if I did 360, how much more do I need to go? 330. You're going to have to do this without a calculator, right? So 330. So 330, that's right there. That means I'm in quadrant 4. Okay? Now, what's the reference angle? If I stop at 330, what's the reference angle? 30 degrees. Okay? Now, it's 30 degrees. Is that the smaller or the larger angle? Smaller. It faces the smaller side. Now, everybody look up here for a minute. Tangent, we always said, was the opposite over the hypotenuse. If 30 faces the small side, that's 1/2. Over the other side, that's root 3 over 2.
Wait, no, isn't cosine of 30 always? You draw it out.
Okay. Tangent is what? Tangent is y over x. Is that right? Yeah. Is tangent y over x? Okay. Y is always the vertical. If 30 degrees faces the small side, then that y, the vertical, is 1/2. That's your y. Over, if that's the 1/2, then that's the root 3 over 2. That's the x. Okay? Now, when you have the same denominator, you can just make them go away. So this is 1 over root 3, which is root 3 over 3. Okay, now, in this quadrant, is tangent positive or negative? Positive or negative? Negative, yes, sorry. So negative root 3 over 3. Okay? Okay, all students take calculus. That's the mnemonic. Okay, so guys, listen for a minute. If you miss a class, you've got to go and watch the screencast. Okay? Now, here, so those of you that weren't here last time, I did a screencast. Here, all the functions are positive. Here, only sine is positive. Let's do that later. Have a seat. I know. We can do it later. Only sine is positive. Tangent and cotangent, tangent and cosine are negative. Here, tangent is positive. Sine and cosine are negative. Here, cosine is positive. Tangent is negative. All right? It is. Yes. It did click with you last time, didn't it? Yeah. If you can visualize where it lies, then you don't have to draw it. Okay, let's do one with, let's do this one, D. All right? Okay, when you have it in radian, no. We do not go back and forth because I need you to be comfortable with radian equally. Because when you go to pre-calc, you don't have time to get used to this radian business. So we need to get comfortable with it now. Okay, so now, if you have 11 pi over 6, right? What did I say? How would you find the reference angle? It's pi over what? Pi over 6. That's it. That's all it is. It's pi over 6, which is the smaller angle. So between the pi over 3 and the pi over 6, okay, this is the smaller angle. So which side does it face? It faces the smaller side of the 1/2. So if it faces the smaller side of the 1/2, how much is this one? √3 over 2. Now, is cosine the vertical or the horizontal? The horizontal, so it's going to be the √3 over 2. Okay. Is pi over 6 the larger or the smaller angle? Okay, Milan, you and I need to get together at bonus next week. Can we do that? Okay. Okay.